Okay, hi, I'm Dhruv and I'll take chemistry. At least give me a basic introduction. I will forget everybody's name. That's it for formality. Huh? I'm sure. You are? Engineer. There, Sudan. Sudhan. Then under a bit. I talked to one of you from. I- Did I talk to any of you before? No? Okay. Okay, bhai. Chalo. So all of you are science students. Okay. So let's start there. What is science? Huh? So, what is science? Hmm? Why did you pick science? You could have studied history. You could have studied, so millions of things to study. Why did you take science instead of commerce? Why science? What is it? Stop, eh? Why? Not gonna have conversation? Don't want it? Okay. I guess this is what we're gonna do for 90 minutes. I'll sit, you'll sit. Unless you answer, I'll not move forward. Let me say something. Yes, sir, let's start with you. What are you? What did you say your name was? Abik. Yes, Abik. Tell me. What is science? Why are you here? What is it? What is science? That's not an answer. Okay. What is the subject? Something you study. Okay. I guess. Fair enough. Why are you studying science then? So, okay. So this is the lesser evil of the two evils. Yeah. Don't like that, don't like this, like this lesser. Okay. No, you don't. Okay. Very pessimistic view of world, but okay. Yes, sir. What is science? Huh? Creating a system to predict. Okay. Interesting. And why science for you? Huh? Wanted to join the system of predicting things. Okay. Interesting. What did you say name was? Amber. Yes, sir. Yeah, yeah. Yes, sir. What is science? What is physics? Uh, Chemistry is more practical than physics actually, but these are like very okay. Whatever, I'll take whatever. And why are you here? Why did you take science? Why not commerce? There's such beautiful subjects like history, English, literature. Not interested in arts. What about commerce? What about science? So how did you make the decision? Why science? Why? There must have been some thought, some instinct, some basis. No? I mean, there's definitely maybe you know it, don't know. Anyhow, fair enough. Yes, sir. What is your name? Sudhanva. Yes, sir. What are you? What is science and why science? Hmm. Hmm. Functioning of? Right. 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 Okay. Very good. Yes, ma'am. Sorry. What is your name, ma'am? Anjana. Yes, ma'am. Very good. Hmm. Biology. Okay. So, of all the subjects that you studied up until 10th standard, these were the most interesting subjects. Okay. Fair enough. Yes, sir. Thank you, sir. Okay. Hmm. Yes, right. Right. Hmm. Correct, correct, correct. Agreed, right. So, according to me, and science is like a the way I understand this for myself and explain this is like imagine the place that you are sitting in, and now go back to the same place sitting in 10,000 years ago. Right, this spot that we're talking about, where you are sitting, this building, this place, right? What would have been around, right? And then now there are two aspects to this argument, and to this point or whatever theoretical experiment. One is that you go 10,000 years ago, what is it? It's all whatever forest, most likely, right? Most likely, huh? No, not this piece of land that whatever we are on, right? Yeah, this would be a sky. That's also true. That this will be a sky. You'll be hanging in air. So imagine the world, physical world around you, the materials around you, not just that, the the materials that would be surrounded by it would be carbon, whatever, wood and all that stuff. And now look at the move forward 10,000 years. Now look at the materials around you, the systems around you. Where does it all come from, right? And that's the second argument. The first point I understand is 10,000 years ago, you come to the same spot, rain is happening. Today, you come here, rain is happening. Okay. A religious person says, it's happening because there's a God up in the sky. I don't think these are like very, I see science as an evolved form of argument, and the basic form of argument used to be religion, I think. That's how I understand it. Or if it's not about religion and science, it could be some other framework as well. So if rain is happening, regardless of what argument you make, rain is happening. Reality is there, right? That thing is tangible, that thing exists, nobody can change that, right? But based on what framework you study something in, how you going to make an argument about the explanation of that thing changes, right? So a religious person will say, what is happening? There is a God up above, and whenever they feel like, whenever you sacrifice, the God will become happy and rain will come down, right? The scientists say, okay, wait, clouds are all colloids. Then they have the friction, there is condensation, then you get water droplets, they come by, right? So it's literally the same thing. It's just whatever is, it's kind of whatever that same way of thinking. Whatever is around you, you're trying to understand it, trying to trying to um, the second part that you guys were talking about, I think that comes as a consequence of it. Because once you have understood something, like if you have understood plus, then you can use it anywhere, any which way you want. Then it's not a problem. But I don't think that's what really science tries to do or has anything to do with it. That's just the application and commerce part of it. The part which is actually scientific, which is kind of the, I don't know, essence of this whole thing. And that's why, to summarize this, I will say it's like a way of thinking. Like, you can use science in how you have to, any problem statement in life now you can approach it. And that could be in a subject, that could be in your life, whatever, anywhere, whatever. You have to go from here to your home, and your home is 15 kilometers away, and there are five modes of transportation that you can use, right? And if you are using brain to optimize and actually understand what is the best method, that's science. It's not limited to physics or chemistry or maths or whatever. Like, I feel like it's really, and I think according to me, that is the part that lacks, that most people lack. It's just they get into the subjects and get into solving questions, which is 100% needed, because that is what will get you to the exam, right? Which is what you are here for, which is your JEE exam, right? But I think that's a very critical milestone. That's what we are for. But I think there is much longer life after that, and I think I feel it's very very vital when we're studying all this, when we're doing all this. Don't like lose sight of that. That it's really about thinking. It's really about, there is a problem statement and how do you approach it, and it's not about, I mean, again, for exam, it is about being the fastest. It's about what actually, if you are a student of science and really interested in science, it's really about coming with the most optimum solution to that thing. And just this thinking process, I think that, and because once you do that for a period of time, you develop intuition for those things which cannot be done or have not been done. And that's how you basically start to chart into the path of unknown. Without that intuition, you cannot go. And that intuition has to be developed. So, and that's why half of chemistry will be history. So let's say the chapter one first we will start. It is called structure of atom. I'm sure all of you know this chapter. So where do we start? Structure of atom. We say, oh, there was a guy named, if you read Indian books, they will talk about Kanad. If you read American, European books, they will talk about Democritus. And from there, people have been talking, then we'll talk about Dalton's atomic theory, then we will talk about Thomson model. Why do we need to learn all that stuff? What is it important? All of them are wrong. Exactly, precisely. They're not, first of all, they're not wrong. That's the first part. What happens, how this framework works is that somebody in the beginning said atom is this, and that's the only thought process they had. The next person that came, they didn't start from scratch. They worked on the thing that was there before. And because they worked on the thing that they were worked on before, they had ideas about, like, okay, this part is working, but this part is not working, right? And then they make their adjustment, claims, experimentation, whatever data they put there. And the next person comes. So, they say, this is wrong, Thomson model is wrong, or whatever, Dalton's atomic theory is wrong. None of them is wrong. They are absolutely correct even today, right? The some parts of them don't add up, which the other person has changed, which the other person has changed. But there's this a continuous chain of thought, like Bohr wouldn't exist without the Thomson model, right? You wouldn't have the modern, what is the modern model of atom called? Anybody know? It's called wave mechanical model of atom. It comes from Schrodinger equation, right? What is it? You wouldn't have it if you don't have the Bohr model. You wouldn't have bunch of stuff. So it's a constant. So I think it's the same thought. That's why 80% of this, not 80% of this, but a large part of chemistry specifically is just history. It's just, even if you study periodic table, they will start from like Mendeley. So still, like a Mendeley, so still has a, that's the biggest change that happened, because that was the first organization, and we use the same organization. Just the how we organize has changed. But sorry, in the modern periodic table, like Newland law of what? Newland law, and what is that first one? Dauvergne triad. right? This all stuff, this stuff, na? You must have studied this. So you start from there. Why do we need to start from there? Just start from what is today, right? Would make more sense. But that will not let you develop a thought. You're not understanding what is the line of thinking in this. So you really have to tap into that. I think if you really want to not just take the data, take the values, put the answer, figure out the fast. That's just maths. I feel for these exams specifically, no matter whether you're studying physics, whether you're studying chemistry, ultimately what you're doing is maths only for these exams specifically, because it's all about problem solving. It's all about problem solving, figuring out ways to solve the fastest, the most difficult problems you can attack in the shortest period of time, right? That's the nutshell of this. But that's not really the nutshell of science. Right? That's why I hear this argument a lot of the time. That somebody says physics is practical. है ना? Physics, what are you talking about? Talk about massless rope and frictionless pulley, like, no? you know, how is physics practical? Chemistry is about actual chemical, and people call that, oh, this is so nonsense, doesn't make any sense, there are so many exceptions. It's, yeah, it's because there are 100 people, 100 people are going to have 100 different behaviors, right? I can't be mad at you because you and you have different personalities. That's how the real world works, right? So that brings to me to the another argument that I want to make is, by every subject is like a language. That's how I understand it. You there is a grammar to it. There is a framework. That is what you need to get to. Whatever your subject is, you need to get to the grammar of it, because once you have it, then you can think. And that's the reason I also say a subject is like a language, because you can articulate anything that is happening around you through that language, and you can understand it. Yeah. If you really do the subject in right way, if you understand the grammar of it, you can construct your own sentences without worrying about whether it's right or wrong, whether it serves or not, because you understand the essence of it. Even if you get wrong, like, again, getting wrong in science, that is what also, getting wrong in science is always allowed and celebrated. That's the difference between religion and science. Religion says, I know everything. You know what makes science better than it? Because it's the only thing, it's the only framework of study in this world which is constantly trying to prove itself wrong. It's the only framework in this world which is constantly the only way. It understood very early that the way to evolve is to prove yourself wrong and find holes in what is there, right? That's how this works. So yeah, I guess that's pretty much it. What I want to say about this. I just want all this to say, first of all, this is a very different subject, chemistry. Let's come to now be more specific than physics and math. Physics and math are more about the logic of the universe, right? So whatever maths and physics you study is pretty much universal stuff, and you're trying to find or work within frameworks which are absolute, right? If 1 plus 1 is 2, then 1 plus 1 is 2, no matter what. You can be here, you can be on Pluto, you can be out of the Milky Way, whatever, like, doesn't matter. These are like truisms, basically, right? Chemistry not. Chemistry is about Earth, where we are living. It's very much rooted in the physical world, and it's a very data-driven subject. You know? So if I want to know about people, what do I need to do? What is the way to know somebody? Huh? No? If I want to know you, what is the way? How do you know somebody? By spending time with them, yeah. Right? Why is this question hard? You, how do you get to know about things, right? You spend some more time. Let's say, for example, maybe some of you are very interested in video games, whatever, or what do you do as you? Something, movies, maybe sports, maybe whatever. So if you watch, let's say, football, some of you, whatever your favorite team, you would know all the name of the players. Let's say you watch European League, but you wouldn't know whatever, like in Spanish League. If you don't watch, you don't know the players of Spanish League, but you will know players of that. Why? Because you constantly watch it again. You watch Indian cricket team, you would know the players of the Indian cricket team. If you never watch it, you would not know. If you hang out with this guy, sit him every day, you will know things about him. If you don't, you won't. So that's literally the difference. Physics and maths, you need to know this much, and then it's all about extrapolation of that information in different pathways, right? Different problem statement, the core remains the same. Now all ability of extrapolation will get you where you want to go. Yeah. This subject is very different. This subject is completely data driven. You need to know certain things about him to be able to make an assumption about him. है ना? It's not, this is not true, there is no truism because this person to this person everything will change. So in this subject, data matters a lot, theory matters a lot. So this power of extrapolation that makes anything science comes very late in this. It can only happen when you know the complete groundwork. Only then you can make reasonable extrapolations of that. Clear? So approach to this subject again, matlab, all these things I always assume most people know, but I'm just saying this because I think I want to highlight these things. See, whenever you're approaching this subject throughout, please don't treat it like maths and physics. It has different nature, different temperament, and always requires more reading, more emphasis on theory rather than just solving. The solving is also an integral part of it. Any subject, any learning has three stages, I think. What are those? First is understanding the concept, whatever that is. You know, just understanding कि भाई, do you know this stuff or not? मतलब understanding or just being acquainted with that stuff. Second is, do you understand the framework within which that is happening? What are all the conceptual aspects of that? And after understanding all that, can you apply that somewhere? Can you use it in a practical application when a problem statement is there? Can you think within that framework to approach that problem? So in maths and physics, the first aspect is very less. It's really about the second and third. Here it's, I would say 50% of it is about the first part. And then the other parts come into picture. Right? So that's a very important thing. So enough of this. Let's start. Anything you want to ask me? You guys are too quiet. You guys are going to become, I think, very evil as time goes by. Your kinds of kids are very difficult. First you are quiet, then you go to the other extreme. No response. Okay. Okay, bhai. Let's start. First chapter, structure of atom. What do you know, bhai? What is an atom? Let's start there. अच्छा, atom से भी पहले कहाँ? Let's start with what is that? Let's start with matter. What is matter? Hmm? Stuff around us. Correct. How do we define this? Anything that has mass and occupies space, or we can say has volume, which means the same thing, right? So as long as there has been civilization, how long do we have civilization for? Hmm? What is the what period starts the civilization? Huh? Not 100,000 years. 10,000 years is basically roughly when agriculture revolution begins, and the foundation of modern civilization comes from roughly around that time. Agriculture revolution is the foundation of modern world. So since that time, again, matlab, what is civilization also? है ना? By before civilization, we used to live how? Now little bit of history. Yeah? Huh? Hunters and gatherers even, right? So we go hunters and gatherers. When we are hunters and gatherers, we are not modifying the world, which is the second point this was talking about. So imagine yourself here 10,000 years ago and imagine now, right? So when you're hunters and gatherers, what were we doing? We were just taking the world was as it was. There was no physical manipulation of the world in any way except for tiny, tiny things, the which were the weapons, right? That's the first modification we started doing. And then when you that is like a very on a very small scale, but as you start to build a civilization, then you are changing matter all the time into shapes and things and forms that you want, that you need, and you need to understand the materials and what can you use, what can you not use, and whatever, right? So as soon as that started, people started to think about things around them. I mean, much before I'm sure would have been, but we'll start from there. We can't go that back. People started thinking. So first classification. So people started looking at stuff around them and being like, what is what? How do we classify? Matlab, how do we put it together? So one of the first earliest classification, what was the first classification? Huh? Five elements. Huh. कि भाई everything that is there is made up of either earth, water, fire, air, and sky or space, whatever you want to call it. So anything that is there, it has these elements in it. So that's what the earliest classification of matter that came into the picture. And since then, people have been just trying to understand and identify what is the core, right? Where does it come from? So these are the people. This was the first guy they credited to. His name is Democritus. And then subsequently after him, different people. You know, Lysippus, this guy they will talk about if you read NCRT, which you must again because I said this is a theoretical subject, na? NCRT is must. Reading and text question at least. Hanging question exercise you can do great if not, but this is so regardless whether we say or not, this is always the homework. Always, every single time. Okay. So if you read NCRT, they will talk about Kannada. Every culture will talk about their guy, है ना? If you read Greek, Latin, Catholic books, they will talk about Democritus. So all these people were this guy first. Before again different kind of categorization, we are jumping all them. First guy to say, wait, there is something which is called atom. है ना? Atom word comes from where? It comes from these two things. Atomas. Tomas is something which is you can divide. A means cannot. है ना? Some thing that you cannot divide further. That is atom. है ना? That is atom. So that idea was presented and then in different form explored by different people. So that idea pervaded till very smart people. Like these names you must have heard. Have anybody heard Boyle? Newton, तो खैर, of course, all of you will know. Okay, but so this by this time, the time we are starting, which is in 19th century, we will start our thing, and that time the idea that people have of atom is that it is something which is indivisible and it is the fundamental particle which constitutes all the matter in the world. What do you mean by fundamental particle, bhai? What is a fundamental particle? What does it mean? Something which is a building block of something. So if I say this building, what is the fundamental, not particle is not, what is the fundamental building block of this building? It will be, although this is very good, but any building would be brick basically. So fundamental particle or fundamental building block means something, if you put a repetition of that, you will get the bigger picture. You know. So atom, at this point we start this story, is what? Is the fundamental particle or constituent of matter. Okay. So all of these people are talking about it. But we credit the atom ka first thing to which guy? First time who talked about atom? Huh? No, but we credit it to, you must have studied this no instance, no? John Dalton. Why? In- Why this guy gets all the credit? Uh, so read this. I think this is very, very fundamental, not to this, but to a lot of things. This applies to politics, it applies to a lot of things actually in life. Clear? So now you know why Dalton is the first guy, and there will also come a town. We'll talk about that, which played a huge role. But this happened in 1804, and this guy, after working for about 20 years, he was not even a scientist. He was just like a teacher. So he worked on this for about 2 decades, and after 2 decades of work, he put down some of the pointers, which are as following. Write this stuff now. Let's start. So, but okay, let's talk about this first. First is all matter is composed of extremely small particles called atoms. Is this true or not, by the way, today? Yes or no? Okay. Second point, atoms cannot be subdivided, created or destroyed. Is this true or not? Can they be subdivided? Can they be created? Can they be destroyed? Atoms can be subdivided, atoms can be created, atoms can be destroyed. Not in our chemistry, okay? So what we study is chemistry, and then there is a nuclear chemistry, which is completely different. Hai na? We're not going to go there, but in nuclear chemistry, you can alter an atom, you can create an atom, and do all that stuff. The second statement as of today is not correct. Done? What are the other points? Atoms of a given element are identical in size, mass, and other properties. Matter of different elements differ in size, mass, and other properties. Okay. Is this statement correct? What is the counter to this statement? I got it. Correct. Next point. Atoms of different element can combine in simple whole number ratios to form chemical compound. Is this correct or not? Correct or not, right? Absolutely correct. And fifth, in chemical reaction, atoms are combined, separated, and rearranged. It's also absolutely correct. Right? Okay, I forgot to ask, how have some of you done some of this stuff of 11th standard before? Which chapter? All of them. Theory. Have you solved anything? What have you solved? From? What did you solve? Photoelectric effect. No, where did you solve questions from? Did you, for example, did you solve module? Did you solve Narendra Avasthi? Module you have solved. Okay. Did you solve VPA sheet? Some of them. Exams is fine. Have you solved material or not? Okay. Any of other, what about everybody else? Have you guys studied this stuff before? Any of you? Not really. Overview. But of this chapter only, not other chapters. Okay. Of this chapter only. Okay. And so then so solving everything is also out of the question. Okay. Not a problem. Okay. Before solving this question, again one more time, what is an atom? How will you define an atom? How will you define an atom? Fundamental building block of matter. I have terrible handwriting, so you'll have to bear with me. Not gonna get any better. Okay, might get good time. Okay, how do you find molecules? What is a molecule, by? Huh? Very simple. Group of atoms. Any group of atoms that are stable enough. So that is so given for anything, you know. Electron, somebody can say electron is also fundamental part, fundamental building block of matter. It is not. You have to talk about the thing which is by itself it can exist. You know? Okay. Nucleus, वगैरह we'll talk about later. One more thing I think we should talk about. Let's say which is you must have done in ninth standard, which is what element compound. What is an element? Let's talk about basic stuff first. Actually, before moving on, what is an element? How do you define an element? Hmm? What is a compound? Okay. How do you define pure substance? Okay. What is the other thing? Mixture. What is mixture? All this you right? Have studied in ninth, right? I'm assuming you studied in ninth, right? In tenth, ninth, you did study, right? You would have, yeah. I'm not really sure where it comes. Ninth it comes, tenth it comes. Ninth. Yeah. Yeah. So what is mixture? Okay, let me ask a question. That maybe you two guys don't know definition, but you know the concept. So let me ask a concept. If you have a compound, let's say this is, let's say water. Okay, so water is out of all these things. Which one is water? First of all, is it an element or a compound? Right, it's a compound. So it's a pure substance or is it a mixture? But it has hydrogen and oxygen. Huh? Yes. So pure substance is the one which have same fundamental particle or only one type of fundamental particle, right? Hmm. Right. So in that, if you have a compound which is made up of same fundamental particle, that fundamental particle can be atom, that fundamental particle can be molecule. That is your pure substance. Okay. If you have only one type of fundamental particle, that is pure substance. Now, if that fundamental particle is atom, then what is the bulk matter of that? That is element. If your fundamental particle is molecule, then what is the bulk matter of that? That is compound. All these things are clear to everyone, right? Yes? All right. Go back to this. What is the answer? It will be molecule or atom. It will be atom. Okay. So, when was the first theory given by Dalton? It was in 1804. Yeah. So, for almost 100 years, almost 100 years, that's how the atom was. You can also call it like a billiard ball model, right? People thought of it, or we'll come to later as well. But this is like an atom is a solid entity, which is, there is nothing inside of it. You cannot cut it, you cannot do anything with it, and everything you just add it in bulk size, you will get either elements or compounds, which will lead you to eventually form all kinds of matter there. That idea gets challenged when the next guy comes. See, this is 1897. This is happening, and that happened in 1804. So almost 100 years, people whatever work they were doing, whatever work experimentations that people were doing, everything was being done on that model of atom. So then in 1897, and that's also a very very fascinating part actually. So most of this you will see, uh, so, some of these people who got Nobel Prize in chemistry, they got very pissed because they got the Nobel Prize for chemistry while most of these were physicists. So most of these people who figured out this work, they were actually working on, what, the lightning. People were trying to understand lightning, how does that work. So most of the work was actually being done by physicists and not chemists really. Um, yeah. So these people were basically trying to understand charge, how does it work, what are the properties of charge, where does it come from, all that stuff basically. So most of the work, as I said, was being done by physicists. Um, the first guy we talk about is in this. So the heading is divisible atom. So this you know already. So 100 years, as I said, the atom was this indivisible thing. Then came something which is called cathode ray experiment, and which told us that is not true. And if that's not true, then all of a sudden the billiard board had a world inside of it. It was not a solid entity anymore. The atom, which was could not be further subdivided, could be subdivided. And if you look at the experiment, I'm sure you must have all have seen this before. Cathode ray tube, cathode ray experiment. It's an extremely simple setup. All you have is a tube which you evacuate basically. You make it as low pressure as you can. Why do you make it as low pressure as you can? Huh? Hmm. Hmm. So how does decreasing the pressure help in that? Easier for us to observe. If you have very high pressure, gas particles will interact with each other a lot more, right? If you, that's what pressure is. You can understand pressure from physical states, right? You can take 1 liter of water and then 1 liter of gas. What is the difference between them? The difference is intermolecular strength. What is that? That's a component of pressure you can understand. Not all the time. It's a very rough thing, but that's how you can understand it. If you have in evacuated tube very extremely high pressure, let's say, then what is happening? The particles are very close to each other, or at least tied to each other. They have more intermolecular force with the other. So in that case, the movement of particles will be what significantly restricted, right? But if you have evacuated tube or extremely low pressure, what will happen? The particles can move very freely and independent of each other almost. Okay. So the setup is very simple. That is what you're going to do. You're going to take a tube. You're going to connect it to a battery, which is then high, which is like a very. This has to be a high voltage source, you know? And that the explanation for this high voltage source is what you're talking about, basically. And we do want to ionize actually. That is what the whole experiment is. If they don't ionize, then the previous model is right because they get ionized, because they get divided, because you get some other charge particles. That's how you get the divisible atom. So you take this and you put some gas in it. Most of the cases is hydrogen, and you put the pressure to be extremely low, voltage to be extremely high, and you have now electrodes. So what do you observe in this? What happens? So that's the setup. So what do we see? We see from cathode a ray, a beam of ray emerging and going to the anode. And then the analysis begin, and then from analysis we conclude things. But that's the basic experiment. Is this clear to everyone? You can write this. Draw this also. Then, so one more time, just to set up the experiment, then you will tell me what actually happened. Is there's a evacuated tube, any kind of tube you have taken, at the end of which you have put electrodes, which you have connected to a high voltage battery or whatever high voltage source, and you have put some gas inside of this. When you actually start the high voltage, what happens? You see a beam of no, you see a a beam of ray going from negatively charged cathode to positively charged anode. And if you put some fluorescent material here, like for example zinc or something, then you will get fluorescence. Okay, at the anode. So now what happened? What is this beam? What is happening in this experiment? Well, that's a whole different matter. I'm just trying to say what happened. Why did we get a this beam? Why did we get these rays? To the other. Exactly. So what happened is, why did we get these rays, whatever we call it as cathode rays, is that the atom is there, an atom has some charged particle which because of very high voltage gets excited, gets ejected out of the atom. And because it is going from negative to positive, we can understand that that particle must be what kind of? Negatively charged. Again, you can also put electric field around and check. There's a bunch of ways to check. We're not going to get into that. But basically, a negatively charged particle, because of very, very high voltage, has been ejected out of the atom, and now they are moving in straight line towards the anode. If you put a fluorescent material, they will strike that fluorescent material and you will get fluorescence, which will also illuminate the path of the beams that you have. That is the entire experiment. Do you understand that? So that's why basically you need high voltage. So if your voltage is extremely high, then the ionization of the atom is going to happen. Nobody can stop that. Clear? So all these are again, any experiment has three things. One is the setup. What are we trying to do? How do we understand it? Then from that conclusions, sorry, observations, and from observations, then we make conclusions. So what does that mean? So when we observed with the ray of beam, whatever we were getting from cathode to anode, we observed these properties. So cathode ray travel in straight line with high velocity and produce shadow of the object in their path. What does that tell you? Huh? What does it tell you? This is an observation. What can you deduce from this observation? Is there something that we can deduce from this observation? So that's all. This is something you're observing, right? From observation, I'm asking you to deduce something. Yeah, so it's a matter, right? If it is has shadow or the object in their path, what is that? It is some solid matter. It's not, right? No, no deduction is that from this. Yes or no? Yes. Second, they produce mechanical effect. Matter, right? We basically what you can do is like put a pedal or like a uh, something that you can rotate and observe a physical effect on. Something very simple. It doesn't have to be complex. Like a fan or like a windmill, tiny windmill or a paddle will do also. It will start to rotate it. Um, when electric and magnetic field is applied, these rays show deflection. And fourth property is the ratio of specific charges we will talk about actually. So that's talked about before. So in the next beginning of next class we'll talk about this. The specific charge, which is E by M ratio, is same for all cathode rays irrespective of the gas used in the tube. What does that tell you? This is the most important bit. What does this statement tell you? kind of atom that you are taking. That means what? That means it is a fundamental particle to all the matter that there is. It must be present in all the atoms, present in the same way. Hmm. We have established that it is actually matter. We have established that it is negatively charged. We have established that it is present in all the matter. Right? So based on this, the guy called it corpuscles. The name that Thomson gave to these things, he called them corpuscles. And then later on, people called it what? Electron. So cathode ray is nothing but a beam of electrons. So these particles are emitted by negatively charged cathode and repelled by negative terminal of an electric field. So Thomson concluded that these particles have a net negative charge, and these particles are now called electrons. Okay. And this again we have talked about. Thomson found that the mass to charge ratio of cathode rays is independent of the nature of the metal electrodes or the gas, which suggests that the electrons were fundamental component of each metal. Don't write this whole thing, but write at least summarize this and write in 2 lines this whole thing. No need to write this all this stuff. Just summarize this and write in 2 lines. The important bit. Which is what? That a negatively charged particle electron, and then it is independent of nature, hence it is a fundamental particle. These 2 points. Okay. So now, what is it or saying? What same specific charge for everything? What is the same specific charge? The same specific charge is 1.76 into 10 raised to the power 11 coulomb per kg. Okay. Whatever that particle they called a corpuscle, the specific charge for that particle, this is specific charge. I'll talk about charge more tomorrow. Specific charge, and it is 1.76 into 10 raised to the power 11 coulomb per kg. Yeah. What is charge in one electron? It is 1.6 minus 1.6 into 10 to the power minus 19 coulomb. It comes from Millikan experiment, which we will talk about. And mass of electron comes from, because once you know this and once you know these value, so this experiment mainly gave this. This is what it was able to deduce. This value we got from Millikan experiment, and once you have this value and this value, you can get this value. Okay, write this stuff. Okay, why? The interaction, it minimizes the interaction between the atoms basically, atoms of the gases. The specific charge of particle discovered dependent on the nature of gas? No. Oh, you did this question? Yes, you can. This question you write. Write this question in your notes. This one question you write and this question you write. It might seem like a very tedious and silly thing to write questions in your notes because it takes its time. But the idea is, again, because of theoretical subject, you want to have such a set of notes which when you time revision time you go back, you don't have to do anything else. There are some questions in that and everything. You know? So just have a little faith and write all the questions. Not all the questions, but whatever we're supposed to write. Done? What is the answer? Hmm? What is the answer, bhai? Answer is option D. Nature of the emitted electron depends on the nature of gas present in the cathode ray tube. Okay. Chalo. Next. Anybody has any doubt in this? No? All right. What is next? Okay, there is one more question. I need to write this one, this answer. This will be. What do you need? You need very low pressure and very high voltage. Why? Because we want isolated atoms separate from everything, and then we want to ionize that atom. High voltage helps us ionize that atom, low pressure will give us that atom. Okay. Next is anode rays. So the setup is the same, है ना? But again, what happens is when you are working and figuring this out, you are, basically the framework is just that you don't focus on anything else, because at the same time when you're doing this, bunch of things are happening. But you're observing what you're observing, and you curate your apparatus, thinking everything aligned in that direction. And it takes literally years and years and sometimes decades to figure all that out. So the setup is same for anode ray experiment, but different set of people did this. The credit goes to Eugene Goldstein, although there are people before who did the same with neutron as well, because of whatever, multiple reasons. Let's not go there. But the setup and experiment is same. So when a gas is capped at low pressure and high voltage, a discharge tube gets the gas start conducting electricity because they ionize. The ray consisting of positively charged particles produced due to the ionization of gas present are called canal rays or anode rays. So now, what is this? What is this anode ray? Can you tell me? Based on cathode rays, what happened? How did we get anode rays? Is this the proton coming out now? No. Then what? What is constituting anode rays? Nucleus. It's not the nucleus. It's the remaining cation. In case of hydrogen, it will be nucleus, because if you remove the electron, you're left with nucleus. But if you take helium atom, or if you take beryllium atom, or any other atom, what is there? What did you do when you put high amount of charge or voltage across that gas? What are you doing? You're ionizing that gas. What does ionization mean? That electron will go and now you'll have a cation, right? So it's the same way the anion is being directed towards the positive electrode. The cation will start moving through because of the virtue of that high voltage towards the negative electrode. And that beam of positive cations directed towards or directed towards cathode will be what? Anode rays. Clear or not? Okay? You can write this part. Make sense? So now, one property instantly from this we can say, anode rays, if I ask you, will they be dependent on the material or the gas that you are taking in the tube? They absolutely. You understand? Second question, I ask you another question. Okay. Statement 1, true or false? Cathode rays emanate from cathode. True or false? And second statement, anode rays emanate from anode. True or false? Can you tell me? First statement is it's true. Cathode is a negatively charged electrode. If at high potential, it will start emanating electrons. Gas particles will be there. It will start emanating. Second statement, anode rays emanate at anode. Will that be true or false? That would not be true, because these are ions which are where? They are all over in the evacuated tube. What is the electrode potential doing? It is aligning and giving it a direction for movement, right? They are not emanating from anode. Do you understand this? Okay. The setup, as you can see, is same. है ना? You have an anode, you have a cathode, you are supplying, and then अभी बिल को any point which does not make sense. So mass of positively charged particle depend upon the nature of gas present in the discharge tube, right? Why? Because they are cations. Every cation is different from the other cation. Second point, charge to mass ratio for anode rays depend upon nature of gas. Same point. Third, when electric field, magnetic field applies, so deflection, which is just telling you what kind of charge it has. This is clear, bhai? So why are we talking about proton? If we are saying cation, how would we get proton? Hydrogen. No? Hydrogen has nothing. One electron, one proton, one neutron. So if I remove somehow ionize an hydrogen atom, what I get is proton. What? That's not right. Okay. What is the answer? Yes. Why? Somebody asked why. What is the answer to why? Because it is made up of cations. Because it is made up of cations. Next, don't need to write any of this. I'll tell you this. E by m ratio of anode rays produced in discharge tube depends upon nature of the gas filled, nature of anode material, nature of cathode material. Which one? Nature of the gas filled in the tube. Next, the cathode rays are made up of electrons. Anode rays are made up of. This should be very, very clear. Okay, bhai, no confusion here. What is the answer? C. Positive residue of atom. Okay, chalo. This will start next class. Yes. Okay, bhai. So this I will remember sometime. I will not remember sometime. NCRT is a must. Like that is something you have to do in this subject. It's essential. Matlab, this is not a subject which is about how hard or difficult problem you can tackle. You know, it's not going to be. There is always a jump from mains to advanced, no matter what the subject is. But if you really understand the framework, you can pretty much figure out anything. How much of the framework you understand depends upon theory. So, you know, it's not always about doing the hardest thing, Please do NCRT, always read it, solve it, and you can do 1 to 5 page per module, read theory, whatever in text questions are there, do that stuff. है ना? Page 1 to 5. Okay? Chalo. Do that stuff and I'll see you tomorrow. It's Bharat Reddy. I do take mathematics in this particular branch. So, what are your names? What is your name? Anshu. Anshu Day. You're the one. Yeah. Anjana. Sujanva. I've seen you, last time. Sudanva, right? Jairi. You are there in 10th here only, right? Both of you, yeah. Abik. Yeah, you are also there, right? Number. Nice. So, chemistry class. Fine. Max for you will be usually taught by Aman sir. Okay, so now sir is having some fever and all that. So, I will be also taking classes in between. Whenever due to some unforeseen situations when sir was not able to take class, I will be taking you the classes. Okay. You guys have got the modules with you? You are taking the modules also. Nice. So, first chapter in mathematics, if you look into it, what is that you are having? Basic max. Okay. So, what do you think will come in basic max? In physics also, I am sure basic max only must have started to you, right? So, what you'll get in basic max over here then? So, what is the difference between that basic max and this basic max? Any idea? Right. So, in physics, what you'll be learning is, because in physics also, like everywhere, mathematics is required, right? Where certain places differentiation is required, certain places integration is required, certain chapters trigonometry is required. Okay. So, how much part of max is required for physics? That will be covered. Okay, so that is complete mathematics. Whatever is required for physics, that will be taught over there. Okay, like certain part of trigonometry, part of differentiation, part of integration. Okay, so whatever is required, that will be taken over there. But here, when I say about basic maths in mathematics part, okay. Let me give me a second. So, what do you think you will get in mathematics basic part? Something you will be there. You must have already have idea, no? Already. Hmm? Yeah, so you'll be getting starts with number system and all that. Algebraic identities, inequalities you'll be getting. Okay. Then logarithms, modulus. Okay. So this basic maths in mathematics is something which will be coming in the upcoming chapters of mathematics. Okay. So like inequalities will be there in each and every chapter in mathematics. Majority of the chapters will be getting inequalities. Like modulus, logarithms in each and every chapter, somewhere they will be trying to introduce modulus or logarithm. So this is what is the basic which is required for the all upcoming chapters. That is what is going to be taught in these chapters. Okay. By the way, like you are from CBSE, ISC, or state board? Anshu, you are from CBSE. Anjana, right? Anjana. Your name is Amber, CBS. Everyone is CBS. Nice. So, how did your exams went? Good. 95 plus percent. Expecting. Open. So then, what? Nice. Is the max paper game difficult or what? Which paper? I mean, max or physics? Max. It was set 3 was difficult. No, it was lengthy. Okay. So, how many of you got set 3 over here then? It was 3 or difficult. Not that. How do you felt? Not that bad. You were able to attempt complete paper, no? Easily. Nice. Basic Max, lecture number 1. Right. Today we'll see about the things which are already known to you. Mostly you have seen it in the length, your 10th standard, which is about algebraic identities, right? So we'll see about that part, algebraic identities. And some questions about that, okay? So, because I hope already you remembered algebraic identities, I'll just give some of the questions which were easy only. So, let us see. For example, try this question once. Right. What are you trying to do here? What is the idea in this question? Yeah, I'm expecting from Sudan. What is the idea behind this question? What do you do? Multiplication, term by term multiplication. Okay. So how many of you are trying to do term by term multiplication? No? Okay. So what is the idea for you? Identities. Okay. Which identity will be helpful over here? Yeah. A cube plus, because if I see here, so this is cube root of 4. I can add as 2 square power 1 by 3. This is cube root of 10, which can be written as 2 into 5 power 1 by 3. This is cube root of 25, which can be written as 5 square power 1 by 3, right? And if you observe the next bracket, you're having something in the form 2 to the power 1 by 3 plus 5 to the power 1 by 3, right? It is looking like to me now something in the form I can write as a plus b, a square minus ab plus b square, right? It is straightforward in the form to you a plus b into a square minus ab plus b square. So which is going to be a cube plus b cube. So my answer is directly I can say cube of the first term, which is 2, cube of the second term, which is 5. So your answer is going to be 6. Right? So there's a pattern over here in the numbers. A cube plus b cube form you're getting it, right? Easy, isn't it? Yeah. Example, yeah. Let's look at this question. These are something which are almost your 10th standard part, right? Maybe a little bit higher level. So maybe for the first or two, 1-2 classes, we'll just see some problems of 10th standard level, okay, and then we'll be starting the main syllabus. 10th a little bit more than that. Okay, it's just to gauge how your preparation went and how the level of the class is, the students in this class is there, so that we'll get an idea. First try this question. Got it? What is the answer? 13. Yeah, first focus on this question. Okay, we'll try this question first. Yeah, Amber, got any idea for first question? Squaring on both sides. Yeah, got the answer? How much? Minus 13. Okay, you got plus 13, right? Yeah, I think answer is going to be 13. On this side. Yeah. Try to think in terms of the algebraic identities. That is what will be helpful over here. Algebraic identities, formulas, what you are aware. Shall we discuss or you want some more time? Discuss. Yeah. So you have here a plus b plus c, ab plus bc plus ac and abc. Three values are given to you and they are asking you to find a power 4 plus b power 4 plus c power. So how do I get this 4th degree expression, sir? What do you think? How do you get this 4th degree expression? So because in identities, what formulas are known to you so far? Do you have any formula in degree 4 in identities? Up to which degree formula you know? What is that formula? Yeah, a cube plus b cube is one formula. A cube minus b cube is one formula. And apart from that, do you know any formula with three terms? Because here a, b, c are there, no? So do you have any? Do you remember any formula with three variables and in cube 3? Okay, a plus b plus c whole square. Then anything like a cube plus b cube plus c cube. Fine. We'll go with that a plus b plus c whole square formula only then. Okay. So what is the formula for a plus b plus c whole square? You know a plus b plus c whole square is, I'll get a square plus b square plus c square plus 2 times of ab plus bc plus ac. You can also write the same formula in one more way. What is the other way you can write? I'm doing one thing, I'm writing it as sigma a square. Okay. So sigma, do you know the meaning of the symbol? All of you. Right, sigma means repeated addition. There are three variables here. So first a square, then next term is b square, next term is c square. You can add as 2 times of sigma ab because it's a cyclic manner. Or what you can do is I will multiply and divide with c. So I can write the same formula in this way, right? Sigma a square. Okay, if I take ABC common, so 2 times of ABC means I'm multiplying and dividing with c for the first term. Next time I'm multiplying and dividing with a. Then what I'll get here, sir? 1 by c, 1 by a, 1 by b, right? That means I can write as sigma 1 by a. Get fine? So this is the other way of writing this formula. What I'm doing is I'm trying to write, because there are 3 terms ABC. In the first term multiply and divide with c, you will get ABC by c. Right here also I will get ABC by a. Last time I will get ABC by b. If I take ABC common, then what is left over? 1 by c plus 1 by a plus 1 by b. It is 1 by a plus 1 by b plus 1 by c. That again you can write in this way, right? Okay, we'll write the formulas also. I'll write the formula list also again. Now I'll try to use this formula over here. So how can I bring that formula into picture? Because I want a power 4 plus b power 4 plus c power 4. So how do I get a power 4 plus b power 4 plus c power 4, sir? Instead of a square plus b square plus c square whole square if you're having, then you will get, right? So if I try to write a power 4, sorry, if I'm writing something in this way, a square plus b square plus c square whole square. Instead of a, if I write a square, then I will be getting here now a power 4 plus b power 4 plus c power 4. Plus I can do one thing, I can write it as 2 times of what is left over here now, a square b square plus b square c square plus a square c square. So to find this, I want this expression and this expression. I want now a square plus b square plus c square value. I also want this value. Now let us think about it, how to get that value. This again, I'll take it to the next slide. Now how do I get a square plus b square plus c square, sir? It is very easy. So I know a plus b plus c is 1. So in this formula, if I replace a plus b plus c as 1, so 1 square is equal to, I'll have a square plus b square plus c square plus 2 times of ab plus bc plus ca, which is another 2. So I am getting from here a square plus b square plus c square is 1 minus 4, which is minus 3. Right? So I have got this term. Now I want this value. Now how do I get this now? A square b square c square. This is b square c square. Okay. So how do I get a square b square c square plus a square c square? Again from the second thing which is given to you, if I square it on both sides, you already know here AB plus BC plus AC is what, sir? 2. Okay, let me name it as 1. If I am trying to square this on both sides, then what will happen, sir? Right, you're able to understand. If I'm trying to square this on both sides, so the first term is going to be now a square b square. Second term is b square c square. Then again I will have a square c square plus 2 times of, if I multiply these two terms, what I'll get? AB into BC. A b square c I will get or not. So I'll have 2 times of ab square c. If I multiply these two terms, then I'll be having here a b c square. And if I multiply first and last terms, a square bc, this is equal to somehow something like 4, right? That means I can say now here from this sigma a square b square plus, can I take anything common over here? If I take abc common, then what is left over again in the bracket? A plus b plus c is what? 4, right? That means I am getting again here now sigma a square b square value as, because I know other values now, abc value is known, which is 2 times of 3 into a plus b plus c. What is that, sir? Again 1 is equal to, so I can say now here I am getting sigma a square b square value as what, sir? 4 minus 6, which is minus 2. This is what is second equation. Now I think you can substitute that 1 and 2 over here, right? And then you can get the answer. Is it understood? So if I am substituting that both things, so at the end what I will do is, now from 1 and 2, I can substitute a square plus b square plus c square value as minus 3. So I will have now minus 3 whole square is equal to sigma of a power 4 plus 2 times of sigma a square b square value, we are getting it as minus 2. Right? That means I am going to say now here sigma of a power 4 value is going to be 9 plus 4, which is 13. So 13 is the answer. Is it fine? You have seen your mistake. Next one you got 18. Number. You understood this, right? So you're simply using algebraic identities only. But first I'm trying to find the value of a square plus b square plus c square. Once I get this, again I'm squaring it to get a power 4 plus b power 4 plus c power 4 value. If I square this is what I'll be having it. And to get a power 4 plus b power 4 plus c power 4, I required a square plus b square plus c square value and this value. So a square plus b square plus c square, directly here I will get it. And to get this a square b square plus b square c square plus c square a square, so square this again on both sides. Got this? Clear to everyone? Right? You can take this question. So others, like, I'll write the other question which I want you to solve. Similar question, similar format of question. Alpha plus beta plus gamma. I think I given 6, right? What is the question, bro? What is the previous question I've given? Alpha plus beta plus gamma is 6. Yeah. Yes. Yes. Correct. 2, 6, 8. Then find alpha power 4 plus beta power 4 plus gamma power. You got this one? Huh? This one you got it? Got this? You keep trying this question first, okay? We'll focus on this question and then we'll go back to that question. Try this question first. All of you are comfortable with sigma notation, right? Okay, because in this question there are three variables alpha, beta, gamma. When I write sigma alpha square, cyclicity, alpha square plus beta square plus gamma square. What do you do in this question? I want alpha power 4 plus beta power 4 plus gamma power 4. What is the idea you're getting, more? Anyone? Most of you are doing in the correct way only. So first I will try to square this on both sides. If I square this on both sides, then I will be getting something like alpha power 4 plus beta power 4 plus gamma power 4. Okay, plus 2 times of AB plus BC plus CA. So that will give me 2 times of alpha square beta square plus beta square gamma square plus again alpha square gamma square. So that is something like 36. Okay, now again how do I get alpha square beta square plus gamma square alpha square value? What do you think we can do? So because I am having here sigma alpha is equal to 2, I'll do one thing. I'll use this relationship here now. So alpha plus beta plus gamma is 2, right? If I square this on both sides again, then what I'll be getting, sir? I'll be getting alpha square plus beta square plus gamma square, which is sigma alpha square plus 2 times of sigma alpha beta, right? Is equal to 4. So this gives me now here alpha beta plus beta gamma plus alpha gamma value, right? Is equal to 4 minus 2, 2 by 2, which is 1. So I was able to come up to here. So if I want again this value, I will try to square this on both sides. Is it fine? If I try to again do the squaring on both sides for this part, then what I'll get? I'll have sigma alpha square beta square will be there as it is. That is fine, right? Then what is there left over? 2. Just now we have seen it in the previous question. Also it came in the same format, right? 2 times of, I can say, alpha beta gamma into sigma alpha is equal to 1, right? Is it fine? Minus we are getting because this is already 4 sigma alpha. Sigma alpha square is 6. My bad. I have taken it as 2. Okay. So sigma alpha square is 6. So since it is 6, you will get 4 minus 6. You will be having 2 divided by 2, which is minus 1. Okay. And again, when you are squaring it, you will get this. So I know sigma alpha value is there. I don't know alpha beta gamma value. So how do I get alpha beta gamma value now? So how do I get alpha beta gamma value? Hmm? Okay, whatever. What you done? You're going in the same way? You're done the same way. So how do you get alpha beta gamma value? So do you know this formula? A cube plus B cube plus C cube minus 3ABC formula? You guys remember this formula? I'll use this list anyhow again. So this is a formula for A cube plus B cube plus C cube minus 3ABC. How many of you know this formula? Just raise your hands once. You don't. Yes, you know it. What about you? But you forgot. Okay, so this formula for this is A cube plus B cube plus C cube minus 3ABC. You'll have a formula something in this way: A plus B plus C into A square plus B square plus C square minus AB minus BC minus AC. Okay, or the same thing one more time, what you can do is you can write the same formula. Okay, I'll do this list again right now. Okay, after this question we'll start writing the list of identities what are already known to you. Okay, there's one more way of writing the same formula. The other way of writing the same formula is, you guys remembered it? Yeah, so you can write the same formula like this: a plus b plus c into, so I'll write down the second factor as, if you do some algebraic simplification you can write in this way: half of a minus b whole square plus b minus c whole square plus c minus. Okay, I'll explain this in detail how we are getting it. Now you are able to recall this formula. You have seen it once, right? In your 10th journey you have seen it. I think it's not there in CBSE, right? It's not there in CBSE, but I think when you're preparing for some competitive exams you must have seen it, right? So this is a formula. So I know here now in this particular question, I know alpha cube plus beta cube plus gamma cube value. I know alpha plus beta plus gamma value. I know each of this value, right? So if I use this first formula, no, I'll get the value of 3 alpha beta gamma, right? So I'll try to use this formula now. Let me go back to this question. So what I will do here is, now I know, because this is what is the main thing. So I have got this. I can say from here again, sigma alpha square beta square plus 2 times of alpha beta gamma. Sigma alpha is anyhow again 2. That means I will be having here now 4 times of alpha beta gamma is equal to 1. So to find now alpha beta gamma, I use that formula. If I use the formula now, alpha cube plus beta cube plus gamma cube, a cube plus b cube plus c cube minus 3abc. Okay, the first bracket, if I look into it, it is a plus b plus c. I am writing in simplified format. Sigma alpha can I write? Next bracket is a square plus b square plus c square. I'll add as sigma alpha square minus ab minus bc minus ac. If I take negative sign common, what is it going to look like, sir? Isn't it like something like sigma alpha beta? So now if I substitute over here, so sigma alpha cube is 8. So 8 minus 3 times of alpha beta gamma is equal to sigma alpha is known to as 2. So 2 times of again sigma alpha square is known to as 6 minus sigma alpha beta. And sigma alpha beta again you got as what? Minus 1. So it will become to, you know, here minus of minus 6 plus. So from this I can figure out what is alpha beta gamma value, right? So I will be getting here now 7 to 14. So 3 alpha beta gamma is 8 minus 14, which is minus 6. So I am getting alpha beta gamma value as minus 2. Now if I substitute over here, so I am getting it as minus 8 plus 1, which is 9. So sigma alpha square beta square is 9. 9 to 18, 36 minus 18 will give you 18 as well. It understood? So once I got this value, so I'll let me name this equation as equation number 1. This is equation number 2. So from 1 and 2, I can say sigma alpha square beta square is what is it we can say, sir? I'll substitute over here. I'm getting minus 8. It goes over there, you'll have 9, right? Now I'll substitute the sigma alpha square beta square in the equation, in the starting equation. So therefore I can say now here, if I substitute over there, sigma alpha power 4 plus 2 times of 9 is equal to 36. So I can say my sigma alpha power 4 is going to be 36 minus 18, which is 8. Yeah. Not a easy question on basic maths, I would say. Basically an algebra kind, it is a little bit of moderate level question, we can say it. Moderate plus. Because first time when you are seeing it, it is going to be difficult. Because alpha cube is there, alpha power 4 is there. Now sigma alpha power 5 it is asked. Or sigma alpha power 6 if they are asking you. What if they are asking you the value of alpha power 5 plus beta power 5 plus gamma power 5? Alpha power 6 plus beta power 6 plus gamma power 6. The higher things if they are asking, that is going to be a difficult question. Okay. So that, because do you have any formula for alpha power 5 plus beta power 5 plus gamma power 5? You don't have any formula, right? So for that actually there is a technique. Okay. You will be getting it in what is Newton's method, Newton's law, you know it? Yeah. So there's a technique which is called Newton's technique. You will get it in quadratic equations, theory of equations chapter. Okay, so you'll be getting that in quadratic equations chapter. So there actually it is going to be still easier. You need not do this much of manipulation. So just you will write one equation and within 2-3 steps you will get it. So there if they are asking you any higher power, sigma alpha power 5, sigma alpha power 6, sigma alpha power 7, anything they are asking, it's easy to find out. Okay, you need not know this many of formulas. But in general, by using algebraic identities, easily you can find up to sigma alpha power 4. Is it clear? Right? Fine. You guys have taken it down. One more method you got it. What happened? You'll write one more time. Okay. Got the idea, right? I'll give the formula again one more time. Is it fine? Sure. Got it? DPS East. KV. Which place? KV. Jayanagar East. Huh? Yeah. Okay. You try the other question. Write your name in this sheet once. Name. You don't have registration number, no, right now. Do you have registration number? So when you see this question, no, ABC are some three real numbers. They are giving you some two equations which are satisfied with numbers. So what is the thought process, sir? What you have done in this question? Okay, your multi. Hmm. I mean, you're trying to take some random value. ABC is one you are trying to take it. No. Okay. Correct. Yeah. Okay. Huh. Okay, that 3 you are taking it as a plus b plus c. Fine. Same thing. So here some rearrangement you have done in the question. Okay, so some small modification you should see in the should do in the question. No, it is easy to solve it. So a plus b plus c is known to you as 3, and this is known to you as 10 by 3, right? So look into the requirement. What is the requirement they are trying to ask here? No, so they ask me to find. So because already it is given to me one more thing, which is 1 by a plus b plus 1 by b plus c plus 1 by c plus a is given to you as 10 by 3. Now they are trying to bring in the picture a divided by b plus c, b divided by c plus a, and c divided by a plus b. So how do I get here c divided by a plus b plus c? And I have to get here something like in the form a divided by b plus c, and I have to get c divided by a plus b. How do I get it? So for that, what you do is, so one way of looking into it is, I'll just multiply this equation with 3. I'll take this denominator 3 to the LHS part. So when I take it to the LHS part, so I'll have 3 divided by a plus b plus 3 divided by b plus c plus 3 divided by c plus c is equal to 10 by 10. And I know one identity here, because a plus b plus c is equal to 3, right? Means always here the value of, I can replace this 3 with a plus b plus c indirectly. That means I can say now here, instead of 3 can I write as a plus b plus c divided by a plus b. Or you can think in one more way, you can multiply both sides of this part with a plus b plus c. I am multiplying both sides with a plus b plus c. When I am multiplying both sides with a plus b plus c, so I will be getting here now a plus b plus c divided by b plus c, a plus b plus c divided by a plus c. So when I multiply with a plus b plus c, I know that value is 3, right? In the RHS, you replace that with 3. Then I will have 10 by 3 into 3, which is again what? 10. That is also fine. Okay, either you can replace this 3 with a plus b plus c, or you can multiply both sides with a plus b plus c. Now what I can do is, I will split into two parts. A divided by, because since I had a plus b over here in denominator, I will keep a bracket for a plus b. If I split into two fractions, the first fraction will become what to me? A plus b by a plus b, which is 1 plus c by a plus b. Can I write it like this? Right. Same way, what I will do for the second part is, since I had in denominator b plus c, I will keep a bracket for b plus c. Then what I will do is, I will write it as b plus c by b plus c is 1. So I will be having now a by b plus c plus 1. In the similar way, what I can do in the last part is, I will write as a plus c by a plus c is anyhow 1. So 1 plus, what is left over, sir? B by a plus c is 10. So a by b plus c, that is what is the requirement, b by a plus c and c by a plus b. So if I take this 3 to the other side, I will be getting the answer as what, sir? 10 minus 3, which is 7. Right? So just don't try to take LCM and cross multiplying it. There is not going to be any help over here. Okay, or you can think in the other way also. You can assume the answer is something like a number k. Okay, the other way of what you can do is, you can just assume the answer is something like k. So I am having k divided by a plus b plus c. K is something like this, b divided by c plus a, and c divided by a plus b, right? Now I will try to find out the value of k, but I know here the value of 1 by a plus b, right? So I will try to add for every bracket 1 1 1. The advantage of adding 1 1 1 for every term here is, LHS I am adding 3, RHS I am trying to give 1 for each term. So I will have again a by b plus c plus 1. It's almost like similar thing in the reverse method you are trying to do it. So plus, you can add as b by c plus a plus 1 plus I can add as what, sir? C by a plus b plus 1. Now if I try to take the LCM, like take each bracket LCM, So I'll have in the first term, sir, in the denominator I'll have b plus c. In numerator we'll be getting here now a plus b plus c, right? So a plus b plus c is anyhow 3. Next term also if you look into it, again I'll have 3 divided by a plus c. Next is also something like 3 divided by a plus. If I take again the 3 common, 1 by a plus b plus 1 by b plus c plus 1 by c plus a, which is again another 10 by 3. So with this also you can see k value is something like 7. Right? Okay. So this is very easy question. It's not visible properly. Okay. I'll add a question over here. X to the power L by x to the power m times of you're having L square plus Lm plus m square into x power m by x power n times of m square plus mn plus n square into x to the power n by x to the power L times of n square plus nl plus L square. What is this value? Simple. Anjana, what will do? Now how do you start this question when you look into it? Because don't get afraid when you see a question like there are many variables here, L, M, N, and some exponents are also there. What I have to do it? So what idea you're getting? Something should be striking to your mind, right? That's it, done. So you write as x to the power L minus m. Now again you're having whole to see this is x power L minus m rise to the power this. A to the power m whole power n. I can multiply these two terms. A power m into n can I write? So if I multiply these two, then what I'll get? It is going to be something like now here x to the power L minus m into L square plus Lm plus m square. Do you agree? Next term is going to become what? X to the power m by x to the power n. Let us x power m minus n multiplied with again what, sir? It is m square plus mn plus n square. And the last term is going to be something in the form x to the power n minus l. Multiplied with that, I will have n square plus nl plus l square, right? Now, are you getting any formula? A minus b times a square plus ab plus b square. What is it? A cube minus b cube. It is a formula of a cube minus b cube. Just they are given the RHS part. So I can directly write as x to the power L cube minus m cube, a cube minus b cube. Next term I can write as what, sir? X to the power m cube minus n cube. And the last term I can write as what, sir? X to the power n cube minus l cube. This can be written. Now again the base side same, I can add the powers. If you add in the powers, if you see, no, L cube minus L cube gets cancelled. Minus m cube plus m cube gets cancelled. Minus n cube plus n cube gets cancelled, right? Means basically I am getting here now x to the power 0, which is 1. In the question itself they have mentioned x not equal to 0 also. Right? Fine. Is it clear? Do you want some time to write? Fine, no? Share or something. You want some time to write? Right. Clear. Yeah. Is the question visible? No. Fine. There is an equation given to you like this: 4 plus root 15 whole to the power x square minus x minus 1. Another thing which is given to you is 4 minus root 15 to the power x square minus x minus 1 is equal to 8. They're asking you to find sum of all real values of x. For this, you solve this equation and find sum of all real values of x. How much? What? There is some irrational number inside it, 4 plus root 15, 4 minus root 15. If I multiply these two numbers, what will I get? You'll get 1. Okay, so 16 minus 15, which is 1, right? So that means 4 plus root 15 into 4 minus root 15, if you're looking at it, if I'm multiplying these two, you're getting it as 1, right? So one term is reciprocal of other term, can I say? So I can basically write here now 4 minus root 15 as 1 divided by 4 plus root 15, I can write. Is it fine? So one term is reciprocal of other term. If multiplication of two terms is 1, so one term is going to be reciprocal of other term. So I can write down this as 4 plus root 15 to the power x square minus x minus 1 plus now 4 minus root 15, I will write 1 by 4 plus root 15. Okay, if I write like that, then I will be having 1 by 4 plus root 15 whole to the power x square minus x minus 1. So 1 power anything is anyhow 1. So I can write as like this, right? 4 plus root 15 to the power x square minus x minus 1 is equal to 8. Now if I want to solve this equation, how do you solve it? Because same term is coming over here and same term is coming over here. You can assume this entire part as something which is like t, right? You can assume this entire thing as t. Now to me this equation, to solve it, I am having something in the form t plus 1 by t is actually what? 8. So if t plus 1 by t is 8, then if I want to solve that equation, so I will be getting here t square minus 8t plus 1 is equal to 0. I am first trying to find the value of t and then I will find the value of x. If I assume this as t, I am getting it as t plus 1 by t is 8, right? So this gives me now t square minus 8t plus 1 is 0. Now factorization you can't able to do here. So I will use the formula. When I apply the formula method, then what is the value of t I will get, sir? Minus b is 8 plus or minus root over b square minus 4ac. What is b square here now? Minus 8 whole square is 64. Minus 4 into a into c by 2 into 1. So I am getting 64 minus 4 is 60. That means I am getting something in the form now 8 plus or minus root 60, which is again 16 into 5 by 2. If I simplify it, I am getting it as 4 plus or minus, I will have 4 root 5, which is again 2 root 5, right? Means I am getting the value of t as 4 plus or minus 2 root 5. Can I say that? It's fine. Minus b 2. 60 it is. Okay, sorry. It is 60, so my bad. Yes, yes. Since it is 60, I have taken it as 18. Okay. So we are having 60. Okay, so 15 into 4 I will get. Okay, so 15 into 4 means again I will add as 8 by 2 is anyhow 4 plus or minus 15 into 4 root 4 is 2. So I will be having 2 by 2 also gets cancelled. I will get 4 plus or minus root. Now what is the t? As per my assumption, what is t, sir, now here? I have taken t as 4 plus root 15 power this, right? And I have got the value of t as this, right? So for example, so t can be to here two cases. Either it can be 4 plus root 15 or t can also be to you something in the form to you 4 minus root 15. Now I will back substitute the value of t. So to me, as per my assumption, t is to me 4 plus root 15 to the power x square minus x minus 1. So I can say now 4 plus root 15 to the power x square minus x minus 1 is equal to, you will have 4 plus root 15. Or in the RHS again, what I am having, sir, I am having 4 plus root 15 to the power x square minus x minus 1 is equal to 4 minus root 15. Now how do I solve this equation over here? Bases are same. Since the bases are same, can I compare the exponents? So I can compare the exponents and I can say here I will get x square minus x minus 1 is equal to 1. It will give me x square minus x minus 2 as 0, or I will get it as x minus 2 into x plus 1 as 0. So I am getting two values of x here, which is minus 1, 2. Is it fine? Right? And here, how do I compare it? Bases are not same. But I know one thing, 4 minus root 15 is exactly what? Reciprocal of 4 plus root 15. Both are reciprocals to each other. So can I write 4 minus root 15 as 1 by 4 plus root 15? And 1 by 4 plus root 15 is exactly same as what, sir? It is 4 plus root 15 to the power minus 1, can I say? Can I like this? Now again bases are same, so I can equate the exponent. When I'm equating the exponent, what I'll get, sir, I'll get x square minus x minus 1 is something like minus 1. So minus 1 gets cancelled. You're having x square minus x as 0, or x into x minus 1 is 0. You're getting x values as 0, 1. So 4 different roots I'm getting it, minus 1, 1, 0, 2. These are the 4 different values of x. They're asking you to find the sum of all real values of x. So addition of this will give you the answer as what? 2. Is it clear? Fine. Okay. I think the class is up to 125, right? Fine. We'll write the formulas once today. Now the list of formulas what is there in your 10th standard we'll write once. So starting from a plus b whole square, these are known to you, right? So let us quickly write the formulas once and we'll wind off this today's class. The very first formula we'll have is a plus b whole square. I'll do one thing. I'll just write the LHS part. You can fill the RHS part. Okay. So a plus b whole square formula, a minus b whole square plus a minus b whole square. These are known to you already. A plus b into a minus b if you're having it. Do you have any formula for a square plus b square? Okay, so next formula so you'll be having is a cube plus b cube. A cube minus b cube. So a cube plus b cube, what is the formula known to you? A plus b into a square minus ab plus b square. Okay, so after this, what other formulas you have studied? A plus b plus c, a plus b whole cube, yeah. So a plus b whole square is done. So we'll see in cube with only two terms, a plus b whole cube, which is a cube plus b cube plus 3a square b plus 3ab square, or I can write as 3ab into a plus. A cube minus b cube minus 3ab into a. Okay, in fact from this only you can also derive a cube plus b cube formula also, right? Take the other term to the LHS part and take a plus b common. You will get a cube plus b cube formula from here, right? And a plus b whole cube formula, this you're just multiplying the same thing 3 times. Do term by term multiplication, expand it, you'll get this. Next, with two variables, any other formula you are having? Only with two terms. A plus b whole power 4 and all that, that's not required to you right now. But even if you want to write it out, binomial theorem, if you're having an idea, you can use the binomial theorem logic. You have any idea of binomial theorem? Okay, fine. So up to this much is fine. So one more thing what I'll say is, if I have a power n minus b power n, so what is the formula for this? A square minus b square, a minus b is a factor, a minus b into a plus b. A cube minus b cube, if you see a square minus b square formula, no, it is a minus b into a plus b. A cube minus b cube, a minus b into another factor I am getting it, a power 4 minus b power 4 also if I look into it, no. If I want to just write for example a power 4 minus b power 4, I can simply factorize it, write as a square whole square minus b square whole square, right? And again, if I'm trying to write factors, I'll be having here now a square plus b square into a square minus b square, which can be written as a minus b into a plus b. Now, if I multiply a square plus b square into a plus b, no, this is going to fit in this way. I'll have one factor as a minus b. The remaining things will be something in the form to a cube plus a square b plus ab square plus b. So this gives you an idea, like you also know always a minus b, is it always a factor of a power n minus b power n? A power 4 minus b power 4, you will get a minus b as a factor. In a power 5 minus b power 5 also, I will get a minus b as a factor. So if I want to write any higher power, a power n minus b power n formula, so how do I write it? One factor is always going to be a minus b. Can you say this? It's fine. Now when I want to write the next factor, okay, so if you see here, it's a 4th degree part. I written one bracket which is of degree 1. So the other bracket terms are of degree 3. Okay, so degree 4 is there in the LHS, degree 1 is done. Start with degree 3, a power 3. Now reduce one power for a and increase one power for b. That's what you written is, right? If I want to write, for example, now a power 5 minus b power 5 formula, no, what I'll do, sir, I'll add as a minus b. Next, what I'll do here, I'll start with what? A power 4. So a power 4, now I'll reduce one power for a cube b power 1. Next, a square b square. Next, I'll have a b cube b power 4. This fine? Okay. So if I want to write the formula for a power n minus b power n, so it is a minus b. So next bracket I'll have what? A to the power n minus 1. Degree n I have to get it. Already degree 1 is done. So write degree n minus 1 terms. So next time what I'll have here now? I'll have reduce 1 degree for n for a and increase 1 degree for b. A power n minus 2 into b power 1. If you want to write next term, I'll have a power n minus 3 into b square plus so on, so on, so on. So last term will have only b term in it, b power n minus. And this is going to be valid when n belongs to what, sir? Some positive integers, or I can say when n belongs to natural numbers. Okay, you can't use it whenever n is rational number, something like that. So always you also know a minus b is a factor of always a power n minus b power n, right? This symbol stands for belongs to, right? This power n, that should be any natural number. It belongs to natural number. Similarly, what you can say about a power n plus b power n? I had a formula for a cube plus b cube, right? A plus b was a factor, but do you have any formula for a square plus b square? Yeah, because don't say, I mean, you can write a square plus b square as a plus b whole square minus 2ab. But I am asking in terms of factorization. Do you have any factors for a square plus b square? No. But for a cube plus b cube, a plus b is a factor. Similarly, a power 5 plus b power 5, you will get a plus b as a factor. So I would always say a power n plus b power n is divisible by a plus b, provided if n is odd. If n is odd, a power n plus b power n is going to be divisible by a plus b. And here you can say it. If you want, you can write as a note also. A power n minus b power n is always divisible by a minus b. Right? But when you have plus sign, a power n plus b power n will be divisible by a plus b. If and only if n is odd. Give me one copy of module. Okay. So we'll see the formulas of three terms in the tomorrow's lecture. If you have I already have given one formula. A plus b plus c whole square is known to you. Similarly, a cube plus b cube plus c cube minus 3abc, that I'll give it in the next class. Okay. So in fact, if you want, you can also have a revision of the formulas from the module also. Page number 2, they are given the formulas. Have a look into the formulas and just give a trial of, just give it a try, okay? Because I think DPP1 you are having some questions, okay? I'll write the question numbers also. Just try to revise the formulas which are there in page number 2 and 3, okay? TYB stands for train your brain, okay? So your module has train your brain means solved example questions, okay? So in that you can try once question number 3 to 5. Train your brain Q3 to Q5. And DPP is also there. So DPP1, question number 1 to question number just 12 questions, okay? If you want, you can try the remaining also, but at least try just 12 questions. Q1 to Q2. It will not take much time. And try these many questions, okay? So tomorrow we'll finish this algebraic identities part. I'll also bring some more questions. Okay, so after tomorrow's lecture, then inequalities will get started. Tomorrow we'll finish this identities part, okay? So the main thing of basic maths is inequalities, because this algebraic identities already you are aware a little bit about of this in your 10th standard, okay? Inequalities, so that is something which will be fresh for majority of the 11th students. You know Wavekar method of solving inequalities, okay? So we'll be, so after tomorrow's lecture, inequalities will get started, okay?